Hello, welcome to F.M Tuition Academy. This is teacher Frank, the genius, the GCE surgeon himself. You know you're somebody who wants to do online tuitions, whether it's mathematics, physics, English, chemistry, biology, civic education, any subject that you want to do. You know that you are somebody writing GCE. Comment your phone number and our team will get a hold of you. Comment your WhatsApp number. Those ones want to do tuitions with us, this is our WhatsApp number. WhatsApp number 260979 22 20 76. Okay, so in chemistry, we'll be looking at a topic called ions. We're looking at a topic called ions. The first thing that you need to ask yourself first is, what is an ion? What is an ion? We're looking at what is an ion. So an ion, whenever you're dealing with atoms, an atom, when you charge it, when you charge an atom, when you charge it, it will either be positively charged or negatively charged. Okay? When you charge an atom, it will either carry a positive or a negative. So these charges that are either positive or negative are what you call ions. So an ion simply means an atom that has been charged either positively or negatively. When an atom, you remember in the previous lesson that we have learned, we learned about an atom is the smallest particle of a substance that can take part in a chemical reaction. So when that smallest, the smallest part, when it is charged, when you charge it, when it becomes excited, it either becomes positively charged or negatively charged. So that's what happens with an atom. When you charge the atom, either positively or negatively, it becomes an ion. So what is an ion by definition? What is an ion? What is an ion by definition? Because in the exam, they can ask you to define an ion. Define it. Define what an ion is. What is an ion? It is, an ion, it is the smallest, an ion is a charged atom, An ion, it is a charged atom. An ion, it is a charged atom. An ion is a charged atom, either positively or negatively. That's what an atom is, an ion rather. An ion is a charged atom. It's either positively or negative. I think I explained that. So sometimes they can give you to say, write the ions for the following elements. For example, I'll give an example because I'm preparing you for exam, so I'm going straight to what is more important. Example, if I say, write the ion for the following elements. You may be asking, saying, where are you getting those things? I'm getting them in my brain. You know, when you have got your teacher who is a genius, he doesn't use a book, he just knows everything in the head. So I know these things. I want to train you to a level where you become a genius as well, so that you're able to clear your exam with a distinction. Okay, so an ion of the following element. One, if I say I say for sodium, for example, the other ion, right, for, let me pick, what can I pick? Sodium, I'm trying to find a simpler one. Let's pick magnesium. Okay? Those are the two. How do you write the ion for this? I'll show you two ways on how you can do it. So for example, we're trying to write the ion for sodium. The simplest way is you go on your periodic table. On your periodic table, for example, I taught you about sodium, magnesium. This is from the first 20 elements. The first 20 elements. And sodium, its nuclide looks like this. When you check on the periodic table, the symbol for sodium is like this. Na, meaning sodium. On top on your periodic table, you'll be using a periodic table to solve this. So on top of the periodic table, on top, you see this is a sodium. This is a sodium. It will look like this. I think you have seen this on a periodic table. The periodic table looks something like this. The periodic table will look something like this. Okay? Some of you may not know, but the periodic table looks something like this. So what you do is on this periodic table, the more you begin to use these elements, you'll be able to tell. Like for example, sodium is usually found in group 1. So you check, is it here, is it here, is it here, is it here, is it here? You look for sodium in all the boxes until you find where sodium is. So for example, if sodium is here, if it's something like this, sodium, you will notice that this sodium atom on top, it will carry a number like 23, like this. And then down it will carry a number like 11. Okay? So it will look something like this. Sodium 23, 11 down. So whenever we are writing the ions, you always use this number down here. Okay? You use that number down there. I said you get this from the periodic table. You look for the element sodium on your periodic table. Check the way it appears. Whether it is here, sodium, whether it's here, it's here, it's here, it's here. I don't know where it is. You look for where sodium is. But the more you practice, you'll be able to tell that sodium is atomic number 11. So this is mass number and this is atomic number. So what do? This atomic number here, you write something like this. Sodium. First you say sodium is number 11, atomic number of 11. Then you say electronic configuration for sodium is 2,8,1. Okay. Then what you do is you check the last number. Okay? You check the last number. Let me write it again here. Sodium is like this. Sodium is number 11. It's 2,8,1. So you check the last number. The last number. So this is the first shell with 2, the second shell with 8, the last shell. You check the last shell, this one. When the number in the last shell is, when the number in the last shell is below 4, it means the ion is positive. Once this number is below 4, meaning if it is either, e.g. if it is 1, if it is 2, if it is 3, meaning below 4, meaning the ion that we put there, it is positive. So meaning when I'm writing the ion for sodium, it's going to appear like this. After writing this is the ion for sodium. I wrote it like this, but how do I put the ion? Since it ends with 1, I'll put 1 like this. I'll follow the rule. The last number, is it above 4 or below 4? It is below 4, so I'll follow this rule. When the number in the last shell, or when the number of, when I say the last number, I mean the number of electrons. When the number of electrons, okay? When the number of electrons in the last shell is below 4, if this number at the end is below 4, write it the way it is, then you put a positive sign. It will be like this, +1. Okay? If this number is 2, then here you put 2 plus. If this number is 3, you put 3 plus. This rule only works when the last number is below 4. Okay? That's how you do it. Same thing when you're writing so this is the way it's going to be. This is the way the ion will look like. It will look like this. Okay? This is the ion for sodium. This sodium atom. This sodium atom, sodium element, but its ion is going to look with it. It's a charged atom. It's an atom that has a charge of positive 1. What about write the ion for magnesium? You check on the periodic table. Where is magnesium? Magnesium is in group 2. You see, this is group 1, this is group 2 elements. You'll be able to find them. So for example, if magnesium is here, for example, you check what number is on top on magnesium. You will notice that magnesium carries 24 on top and then 12 down. Then you now calculate now. You say magnesium, you write it like this, 12, magnesium 24, okay? Then you say EC. You remember I said the electronic configuration, you use this one down. I taught you how to do the electronic configuration in the first lesson. So the EC, okay, I'll wrap this part just for the sake of the calculation. The EC is 2,8,2. Then you ask yourself, what is the last number? The last number is what? 2. Oh, this is the last number. Is it below 4? Yes. So anything below 4 will carry a charge of positive. Then you just write it the way it is with a positive sign. You also write it as a power in front, as a power like that. That's a little on how you write that. This is a first rule. Okay, I'll write the third question here. What about if you're dealing with the, let's say, phosphorus. Okay, if you're writing the ion for phosphorus, what do? So this is the ion for magnesium. Have you seen it? This one. We have written it. This one. It is 12 down, 24 on top, plus 2. You'll be getting these on the periodic table here. Just look for magnesium on the periodic table. The periodic table, whenever they give you a past paper, at the end of your past paper, you're going to find the periodic table. You'll be finding these numbers where there's a number on top, a number down. You find an element with a number on top, a number down. But you're using the number down, this one. That's the one that you use for whenever you're dealing with valencies, when you're dealing with chemical formulas, when you're dealing with ions, when you're dealing with bonding, you'll be using this number down. The number down, that's the one that is involved in all your calculation. Okay. Okay, I'll include question 3. I'll wrap this. What about if they say what is the ion for phosphorus? So you check phosphorus, you check here. Where is phosphorus? You check, is it here, is it here, is it here? No, you can't find. Until you find where phosphorus is, check all the elements. Oh, you have found phosphorus. Phosphorus is P. And phosphorus should be 15. And then here it's 31, if I'm not mistaken. So it will look like this on the periodic table. You see? Of course, it fits in this same box. P here, and then 31, 15. Okay? So it will appear something like this. Phosphorus, P means phosphorus, with a 15 here, and a 31 here. But how do you write the ion for phosphorus? You're trying to find the ion. You follow the second rule. First, you write the EC, electronic configuration, 2,8,5. First, you say phosphorus, atomic number 15, EC, 2,8,5. Now, have you seen this one? It's above 4. You have seen this one? For example, if it ends with 5, it ends with 6, it ends with 7. That one is above 4. So meaning this row can't work. Because the last number is above what? 4. So that row cannot work. Because the last number here is above 4. So you follow the second rule, guys. What does the second rule say? The second rule says, if the number of electrons in the last shell is above 4, subtract that number from 8 and put a negative sign. So if the number of electrons in the last shell is above 4, subtract that number from 8 and put a negative sign. So if the last number here is above 4, you subtract that number from 8. What do I mean? You subtract that number. Since it's 5 here, you subtract it from 8. You get 3. Then you add a negative to your answer. So you're using negative 3. So it means the charge here will be 3 minus. That's how I'm going to write it. So it will be like this. This is the ion. Okay? This is how the ion looks like. 15, 31 with a negative 3 minus. I hope you have understood. So if this number, for example, here it's 6, 6 is above 4. You say 8 minus 6 is equal to 2. And then you put a negative 2 here. Why? Because you subtracted from 8. The 2 here is different from the 2 here. The 2 that is above 4. The one that's above 4 was as a result of subtracting from 8. That's the reason why you put a negative. But when it's below 4, you just write it the way it is. If the last number here is below 4, write it the way it is and then put a positive sign. But if the last number is above 4, such that if, for example, if the last number here is 5, 6, 7, and 8, you subtract from 8, which is the stability number. So don't say where is 8 coming from. This number is a stability. Stability number. It's like a formula where you subtract from. Where you subtract from. You always subtract from this 8. So don't be getting confused saying, sir, where is 8 coming from? It's a rule that you subtract from 8. Because that's a number that is the stability number. For now, just know it's a stability number where you subtract from. For you to know how to do these calculations. So that applies with all the elements. If it's 2, it will be 2 minus. If it is 7, this one, you write 8 minus 7 is equal to 1. So it will be negative 1. Okay. I think I've explained. So these are the 2 rules. When the last number is below 4, write it the way it is. When the last number of electrons here is below 4, write it the way it is, put a positive sign. When the last number is above 4, subtract from 8, put a negative. Okay. All right. I think for this, please take advantage of the periodic table. That's why you'll be finding these elements. Okay, let me give you an exercise. I think I better give you an exercise, guys. So, let me give you an exercise. Just, so exercise, you write the exercise. So, write the ion for the following atoms. Okay, it can either be atoms or elements, it doesn't matter, it's the same thing if I say atom or element, because an atom is the smallest particle of an element. So I'm talking about the same thing, one is smaller, one is bigger. So they can say find the ion for the following element or find the ion for the following atom. So first one, the first one is the sulfur. 1, 2. Aluminium. 3. Chlorine. 4. Potassium. Potassium. 5. Calcium. So you'll be asking, so how do you know these things? They're in the brain. Calcium. So those ones want to do tuitions either in maths, physics, chemistry, biology, RE 2046, civic education, commerce, geography. If you want to do any of these tuitions, contact us on this WhatsApp number. This is a country code for Zambia, 260. And then you can contact me on WhatsApp 0979 22 20 76. Okay? For those ones who are contacting me from outside Zambia, use this country code +26, then you put this number +26 979 22 20 76. Then we'll be able to guide you. Okay, so this is Teacher Frank the Genius, the GCE surgeon himself. I want to help you to get distinctions in mathematics, physics, English, chemistry, biology, civic education, commerce. All these subjects, we are offering them here at F.M Tuition Academy, a place of excellency and distinction. Until then, comment your WhatsApp number, inform your friends that Teacher Frank the Genius is on and is helping us to pass. Thank you very much. Signing out for today.